again, this is a topic that looks real tough when you first look at it, not too tough at the basic level. Same as skill 21, you can only combine like terms. You can almost think of your square root components the same way that you think of your variables in 21. So I can combine terms if they have the exact same thing underneath of the square root. And the way that I'll combine them is I've got 7 of these plus 4 more of these. That's 11 of those things. Minus 8 of them. That's 3 of those things. Plus 6 of them. That's 9 of those things. All right, so 9 of square root of 2. Right? 9 square root of 2s is what I have here. 7 plus 4, 11. Minus 8 is 3. Plus 6 is 9. 9 square root of 2s. All right, so not too tough. Let's look at another one like it. All right, again, I've got 4 of these things, square root of 3, minus 10 of these things, square root of 3, plus understood 1 of these things, square root of 3. So we got 4 minus 10, negative 6, plus 1, negative 5, square root of 3s. Okay? Nice and easy. All I'm really doing is adding the coefficients together. Situation like this, 1 square root of 10 plus 2 square root of 5s, I can't combine them, plus 7 square roots of 10 plus square root of 45, can't combine them. All right, the only thing that I can obviously combine here is square root of 10. All right, so we've got 1 square root of 10 plus 7 square roots of 10 is 8 square roots of 10. Now, here's where like terms could be hidden. This could get tricky. You're going to have to look back to lesson 18. If you didn't handle lesson 18 properly, you're not ready to go any farther with this one. Okay? If you remember from lesson 18, when we have numbers underneath of a square root, we can break them down into perfect factors, perfect square factors like 9, and imperfect square factors like 5, and then simplify that expression by taking the square root of the perfect square. So the square root of 9 is 3, and leaving the imperfect square behind. So square root of 45 is actually the same as this, all right, 3 root 5, and that can be combined with 2 root 5, okay? So we have our 8 root 10 plus 2, 3, 5 root 5 as a final answer. All right, they can't be combined together because I can't break this down or that down any farther. So looking at some more with hidden common factors, at first it looks like we can't do anything with this. We can't combine them because they don't have a common square root component. However, 20 breaks down into 4 times 5. 4 is a perfect square. 45 breaks down into 9 times 5. 9 is a perfect square. So we've got 3 times the square root of 4. All right. That's my 4. That's my 5. That's my 3. And we've got 7 times 3 times the square root of 5. That's my 7, my square root of 9, square root of 5. Okay? So altogether we've got 6 square root of 5 minus 21 square root of 5. Now I can combine them together because we're both square root of 5 terms, negative 15 square root of 5. Final answer. Couple for you to check. You can hit pause, try each of these, see what you can do with them, and then unpause and watch forward to see whether your answers match my answers. Again, if you wanted to test your final answer against the original, you could type the original into the calculator. 8 square root of 75 minus 14 square root of 27 plus 6 square root of 48 and get an approximation, 38.105, etc. Type your final answer in there, 22 square root of 3. Make sure that they match. All right, if they match, you can be pretty sure you simplified correctly. Again, remember I'm looking for perfect squares because those are the factors that I can take a square root of. So we got 2 root 7. 6 times 5 is 30 root 7. 4 times 3 is 12 root 2. And 8 root 2. I'll be able to combine my square root of 7 terms together. 32 root 7 minus, I'll be able to combine my root 2 terms together. 4 root 2. I can't combine each of those with each other though, because the square root parts are different. All right, so a lot of breaking down that had to happen with this. We've got 2 times 2 times 3, square root of 7, plus 3 times 3, square root of 7, plus 3 times 2, square root of 15, minus 2 times 2, square root of 15. That's 12 root 7 plus 9 root 7, 21 root 7. 6 root 15 minus 4 root 15 plus 2 root 15. Alright, again, I could use a calculator to check, is the approximation that it gives me for this in yellow the same as the approximation that it gives me for that in blue? Probably would check that at the end of a quiz if it was such a complicated situation. Alright, but that's basically lesson 22. Like I said previously, if you feel like this is too much for you to handle, maybe you go back to lesson 18 or a previous lesson and say, I'm going to practice this other lesson in place of this so that I can still hand in the right number of practice assignments and take the right number of quizzes.